Saxon Algebra 1, Lesson 4. In this lesson, we will review some arithmetic. Numbers and numerals. A number is an idea. An idea is something that you think about. A numeral is a single symbol or a collection of symbols that we use to express the idea of a particular number. For example, each of the following is a numeral that designates the idea of 1. The first one is the one we use the most. The second one is a Roman numeral. The third one is a collection of symbols. They happen to subtract to 1. 3 minus 2 is 1. Likewise with the fourth one. And the fifth one, 7 over 7, is 1. Each of these is a symbolic representation of the number 1. When we use the word number, we are describing an idea which can be represented by many different numerals. Numerals that represent the same number are said to have the same value. Classifications of numbers. The system of numeration that we use to designate numbers is called the decimal system. It was invented by the Hindus of India, passed to their Arab neighbors, and finally transmitted to Europe around 1200 AD. The decimal system uses 10 symbols that we call digits. They are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We call the numbers that we use to count whole objects, or things, the natural numbers, or counting numbers. These do not include fractions or decimals, and the smallest counting number is 1. So the counting numbers begin as 1, 2, 3, 4, 5, 6, 7, and so on. There is no largest counting number, so numbers like 2007 and 5 quadrillion, 12 trillion are counting numbers. Numbers that include fractions and decimals, as well as the counting numbers, are called real numbers. They also include zero and negative numbers. Positive real numbers are used to describe physical distances greater than 0, like the distance from your house to school, or the length of a nail. For example, all of the following are positive real numbers. The number 0 is not a positive number, but it can be used to describe a physical distance of no magnitude, like the distance from your house to your house. Thus, 0 is included as one of the real numbers. In algebra, we also use negative numbers. These too are called real numbers, and the concept of a negative number turns out to be very useful. In fact, every positive number has a negative counterpart, and we use the minus sign to designate that. We could designate positive numbers by placing the plus sign in front of their numerals, but it is understood that when no sign is placed in front of a numeral, it represents a positive number. Now we consider number lines. A number line is a line with equally spaced tick marks and is a useful aid to understanding relations between positive and negative numbers. We designate one of the marks on the number line as the origin and label it with the number 0. Positive numbers are placed on the right of 0 and negative numbers on the left. If necessary, we can indicate the position of any real number by locating it in relation to the numbers shown. For example, we can graph fractions and decimals as follows. There's negative 3.25, here's 2/3, and here's 4.5. Next, we will look at multiplication and division of fractions. To multiply fractions, you just multiply their numerators and denominators. For example, 4/3 times 7/5 is 4 times 7 over 3 times 5, which is 28/15. That can be split into 15/15 plus 13/15, and then 15/15, of course, is 1, so we have 1 and 13/15. To divide two fractions, you invert the divisor and then multiply. For example, 4/3 divided by 15/8, we invert the 15/8 and get 4/3 times 8/15, and that is 4 times 8 over 3 times 15, which is 32/45. That one doesn't reduce. If cancellation is possible, it is easier if we cancel before we multiply. For example, if we need to figure out 2/3 times 3/7, we have 3 in the bottom and 3 in the top, we can cancel those and get 2 over 1 times 1 over 7, which is 2/7. And another example, if we have 3/8 times 4/7 times 7/15, we can cancel the 3 into the 15. 3 into 3 is 1, 3 into 15 is 5. We can cancel the 4 with the 8. 4 into 4 is 1, 4 into 8 is 2. And we can cancel the 2/7, leaving 1s in both places. This gives us 1/2 times 1 over 1 times 1/5, which is 1 over 10, 1/10. When multiplying or dividing mixed numbers, we must first convert the mixed numbers to improper fractions. This can be done by multiplying the whole number part by the denominator of the fractional part, and then adding the result to the numerator of the fractional part. For example, to convert 3 4/7 to an improper fraction, we multiply 7 by 3 and then we add 4. So we have 21 plus 4 over 7. This gives us 25/7. Let's look at some examples of multiplying and dividing mixed numbers. Here we have 3 4/7 times 2 4/5. That, of course, is equal to 25/7. 3 4/7 is 7 times 3, 21 plus 4, that's 25, times 14/5. Well, 5 times 2 is 10, and 10 plus 4 is 14. But now we can do some canceling. 5 goes into 25 5 times, and 5 goes into 5 once. 7 goes into 14 2 times, and 7 goes into 7 once. So that's equal to 5 over 1 times 2 over 1, which is 10 over 1, or 10. Now consider 12 1/3 divided by 2 1/6. Well, 12 1/3 As an improper fraction, we have 3 times 12 is 36, plus 1 is 37, so that's 37 thirds. 2 and 1/6 as an improper fraction. 6 times 2 is 12, plus 1 is 13. That's 13 sixths. So we have 37 thirds divided by 13 sixths. We invert the second fraction, the 13 sixths, and multiply. So we have 37 thirds times 6 thirteenths. Now we can cancel. 3 goes into 3 once and 3 goes into 6 twice. So we're left with 37 over 1 times 2 over 13, which is 74 over 13. That's an improper fraction. We can reduce it. 13 into 74 about 5 times. If you do the arithmetic, you have a remainder of 9. So 74 thirteenths is 5 and 9 thirteenths. For our third example, we have 3 and a third over 2 and a fifth. Over means divided by. So we have 3 and a third divided by 2 and a fifth. Well, 3 and a third is 10 thirds because 3 times 3 is 9, and then add 1, that gives 10. And 2 and a fifth is 11 fifths because you have 5 times 2 is 10 plus 1 is 11. So we have 10 thirds divided by 11 fifths. We invert the 11 fifths and multiply. That gives us 10 thirds times 5 elevenths, which is 50 33rds. And that is an improper fraction. 33 goes into 50 once, and we have a remainder of 17, so that's 1 and 17 33rds. Symbols of equality and inequality. The equal sign is used when two quantities or numerals have the same value. For example, 4 plus 5 and 7 plus 2 have the same value, so we can write 4 plus 5 equals 7 plus 2. We can also write 4 plus 5 equals 9 and 7 plus 2 equals 9. When two quantities do not have the same value, we use the symbol equals with a line through it to indicate that they are not equal. For example, 4 plus 5 is not equal to 7. If x stands for an unknown number, then an expression like x not equal to 7 means x is not equal to 7. Symbols and terminology of basic operations. There are 4 basic operations in arithmetic and algebra. They are addition, subtraction, multiplication, and division. When 2 or more numbers are added, we use the plus sign between them, and we call each of the numbers an addend. The result of adding them, the answer, is called their sum. For example, find the sum of 3, 5, and 6. In the solution, we realize sum means add the numbers. So the sum of 3, 5, and 6 is 14. Very important. The sum of 0 and any particular number is that particular number. For example, 7 plus 0 is 7. If x is an unknown number, then x plus 0 is x, and we can also write 0 plus x is x. When we wish to subtract one number from another number, we use the minus sign between them. We call the first number the minuend, the second number the subtrahend, and the result the difference. For example, find the difference, 9 minus 5. Well, 9 minus 5 is 4. Difference just means we subtract. The symbol gives it away. The 9 is the minuend, the 5 is the subtrahend, and the 4 is the difference. Numbers which are to be multiplied are called factors, and the result is called their product. In algebra, there are many ways to represent multiplication. You already know about the times symbol. When we use letters to represent unknown numbers, this could be confused with an X, so it is used only for arithmetic. To avoid confusion, we use a dot instead. For example, 3.4 has the same meaning as 3 times 4, so 3.4 is 12. We also use parentheses to indicate multiplication. For example, 3 parentheses 4 is 12, and parentheses 3 parentheses 4 is 12. We could also write parenthesis 3 dot parenthesis 4 equals 12. Very important. Multiplying a number by 1 does not change the number. For example, 4 times 1 is 4, and 1 times 7 is 7. On the other hand, multiplying by 0 always gives 0. 4 times 0 is 0, 0 times 7 is 0. If one number is divided by another number, the first number is called the dividend, the second number is called the divisor, and the result is called the quotient. There are two symbols that are used to indicate division, the divide symbol and the fraction bar. For example, 15 over 3 uses the fraction bar. It's the same as 15 divided by 3. So it's 5. Both notations shown in the example indicate that 15 is to be divided by 3. We call 15 the dividend, 3 the divisor, and 5 the quotient. Now we will review operations with decimal numbers. When you're adding or subtracting decimal numbers, you must align the decimal points vertically. Here are some examples. To add 1.005 and 300.012, write the numbers vertically with the decimals aligned. Then you just add. To subtract 0.02163 from 4.0016, write the numbers vertically with the decimal points aligned again. Then you just subtract the numbers. When you multiply two decimal numbers, you do not have to align the decimal points. For example, find the product of 4.06 and 0.016. Product, you'll recall, means multiply. So we just multiply the numbers, and then we count the number of places after the decimal for our answer. When dividing two decimal numbers, move the decimal point of the divisor and dividend so the divisor becomes a whole number. Then perform the division. For example, to find the quotient of 6.039 over 0.03, you first write it as a division problem, and then move the decimal point 2 places to the right. Do this for both the divisor and the dividend. Then the divisor becomes the whole number 3, and you can perform the division. Notice that the decimal point for the answer lines up with the decimal point of the dividend. Our next topic is unit multipliers. If we multiply a number by 1, we get the same number. So if we multiply a number by a fraction that has a value of 1, we likewise get the same number. For example, 5 over 1 times 7 over 7 is 35 over 7. Both 5 over 1 and 35 over 7 have the value 5. The fraction 7 over 7 has a value of 1, so we have just multiplied 5 by 1. The fractions 3 feet over 1 yard and 1 yard over 3 feet have units and are equal to 1, because 3 feet is another name for 1 yard. We call these fractions unit multipliers, and we can use them to change feet to yards or yards to feet. A unit multiplier is a version of the number 1. The whole point of unit multipliers is they can be used to convert one unit into another unit, like feet to yards or pounds to kilograms. The units in the denominator of a unit multiplier should match the units being converted, so they will cancel, leaving the units in the numerator of the unit multiplier. For example, this 1 can be used to convert yards to feet. Here's an example of using it. 5 yards is the same as 5 yards over 1. Now we multiply by the unit multiplier, and we see that the yards on top cancel with the yards on bottom of the unit multiplier. So that leaves us 5 times 3 feet over 1 times 1, which is 15 feet over 1, or 15 feet. This 1 can be used to convert feet to yards. For example, if we have 5 feet, we can write that as 5 feet over 1 and multiply by this unit multiplier, and we see the feet on top cancel with the feet on the bottom of the unit multiplier, leaving 5 times 1 yard over 1 times 3, which is 5 yards over 3, or 1 2/3 yards. Here are some more examples to show how unit multipliers are used to convert measures of length. Example 1. Use 1 unit multiplier to convert 32 feet to inches. Since 1 foot is 12 inches, there are 2 unit multipliers to consider using. 1 foot over 12 inches and 12 inches over 1 foot. Let's try the first unit multiplier and see what happens. 32 feet over 1 times 1 foot over 12 inches is 32 feet times 1 foot over 12 inches, which is 32 square feet over 12 inches. This happens to be correct, but is not what we wanted, so we will try the other unit multiplier. 32 feet over 1 times 12 inches over 1 foot, the feet cancel. So this is what we want. We get 32 times 12 inches, or 384 inches. We can cancel the feet on the top with the feet on the bottom because feet over feet has a value of 1. So we have arrived at an answer in which the only unit is inches. Example 2. Convert 36 feet to miles. There are 5,280 feet in a mile, So we consider using one of the following two-unit multipliers: 5280 feet over 1 mile, or 1 mile over 5280 feet. Since 36 feet is 36 feet over 1, we use the second unit multiplier because that will cancel the feet. So we have 36 feet over 1 times 1 mile over 5280 feet. The feet cancel. We're left with 36 over 5280 miles, which if you use a calculator comes out to 0.0068 miles. Example 3. Use two-unit multipliers to convert 6 feet to centimeters. We will use the following two facts. 1 foot is 12 inches and 1 inch is 2.54 centimeters. These facts give us four-unit multipliers. 1 foot over 12 inches over 1 foot, 1 inch over 2.54 centimeters, and 2.54 centimeters over 1 inch. We will use the second unit multiplier to cancel feet, and follow with the fourth to cancel inches. So we have 6 feet over 1 times 12 inches over 1 foot times 2.54 centimeters over 1 inch. You see the feet cancel and the inches cancel. So if we multiply what's left, we get 182.88 centimeters. Here we will give a table of equivalent measures. You can find a similar table in your textbook in Lesson 4. 1 foot is 12 inches. 1 yard is 3 feet. 1 mile is 5,280 feet. 1 meter is 100 centimeters. 1 centimeter is 10 millimeters. 1 kilometer is 1,000 meters. 1 inch is 2.54 centimeters. These facts will help you do the homework. Well, that's all for Lesson 4. Be sure to do the assignment, problem set 4, problems 1 through 30, on pages 22 and 23 of your book.